Hi, in this video, I will be showing you problem number 8 of chapter 11 section 7. Test the series for convergence or divergence, sigma n varying from 1 through infinity, negative 1 to the power n minus 1, n to the power 4 divided by 2 to the power n. So this is clearly an alternating series, but to apply alternating series test in order to test for convergence or divergence, the two requirements may not be an easy task over here because of the nature of the function. It is n to the power 4 over 2 to the power n. So the two conditions, one is decreasing, the other one is limit of the nth term equal to 0. Proving those in this particular case is not going to be as simple. So we will do instead the ratio test. The ratio test, if limit is n approaching infinity, absolute an plus 1 over an is L, the limit, and if the limit is less than 1, then the series is absolutely convergent, and absolute convergence would mean convergence, and therefore it is convergent. If limit as n approaching infinity, absolute an plus 1 over an is L, and if the limit is more than 1, then the series is divergent. If the limit is equal to 1, then limit as n approaching infinity is 1, then the ratio test is inconclusive. In other words, you cannot, no conclusion can be drawn about the convergence or divergence of the series. So we'll apply this ratio test over here. So we have to apply limit as n, we have to consider, or we have to do limit as n approaching infinity, absolute an plus 1 over an. But in the given series, the blue one denotes without the sign is n to the power 4 over 2 to the n represents an. So let's consider the ratio test and then the ratio of limit as n approaching infinity, absolute an plus 1 over an. So limit n approaching infinity, an plus 1 will be obtained from an by changing the n to n plus 1. So we get n plus 1 to the power of 4 over 2 to the power n plus 1, and that is for an plus 1, and we are dividing by an, so we can flip and multiply, so that will become 2 to the n over n to the power 4. So I am just flipping the numerator and the denominator here because we are dividing by an, so the numerator and the denominator get flipped. So we can reduce this one, we can actually cross out the common factors. So 2 to the n, and this is 2 to the n times 2. So it will be left with the 2. And we have, so on numerator it is 1, denominator is 2. So it is 1/2 is nothing to do with the limit, which can be taken out of the limit. Then limit is n approaching infinity, n plus 1 to the power 4 over n to the power 4 within the absolute sign, which can be reduced, limit as n approaching infinity, as n plus 1 over n to the power 4. So this limit would become, of course we have that half in front, so it is 1/2. You can reduce this one inside the absolute sign, limit as n approaching infinity, it's n divided by n, which is 1, then 1 divided by n. So within the parentheses you do the simplification. So to the power 4, and then 1 over n will of course tend to 0 as n approaching infinity. So we get 1/2 times, because of the second term getting to be 0, it is just 1 to the power 4, it's 1, that is 1/2. So in the limit, we have this condition that L is less than 1. So that is the condition we have in our case. So it is half equal to L, and L is less than 1. So the conclusion of the first part of ratio test, sigma an is absolutely convergent and hence convergent by ratio test. So by ratio test, sigma an, or sigma n varying from 1 to infinity, which is negative 1 to the power n minus 1 times n to the power 4 over 2 to the power n is absolutely convergent and hence convergent, because absolute convergence would mean convergent. Hope this video helps.